Okay, so I'm going to be showing you some examples of problems that we can be dealing with the Datapath. I'm going to use this Datapath where we have the Datapath for all the instructions, so register type, load, store, branch, and jump instructions, which is the last one that we added to the Datapath. And I'm going to do some examples here, and there is going to be a question very similar to one of these examples in either the midterm or the final. So what I'm going to be doing here is giving values to some of these control signals and ask you to figure out which instruction this is and why. And I might put some wrong control signals there, so to show you how things can be messed up if we change that. So I would suggest that after I give you the data that you need, you stop the video and try to do it yourself, and then play the video again to see what the solution is. So I'm going to start with this one. This is an instruction that has I'm going to give register write a 1. Oops. Let me go back, pick the pen, and register write is going to be a 1. This one is going to be a 1 as well. Okay. So actually, if I give you only these two, you can already tell me which instruction it is. So why don't you give it a try, stop the video now, and try it out. Okay, so let's see what the answer is. So this instruction writes in registers, and it does an operation with the immediate value here, right? This is a 1, so this is the immediate value it's operating with, and it writes registers. So which operations write registers? There are only two operations that can write registers. One is the register type, and the other one is the load instruction, right? No other instruction really writes in registers. So this instruction is writing in registers, so it's going to be a register type or a load. But a register type will operate with these. They all operate with this register, right? But also with these registers. So this one is not operating with two registers. It's operating with a register and immediate value. So for that reason, we can figure out that this is a load instruction. So if this is a load instruction, that means that we can figure out the rest of the signal. It's definitely not a jump. It's not a branch. Do we read memory in a load? Yes, we do read memory. Read memory goes here, so this is a 1. Actually, what we send to the registers to be written comes from what we read from memory. So this is actually what is sent to registers. So this mem to register is going to be a 1. Okay, so this is sent back to the registers. This is the data that we write. We write it in one of these two register addresses. But of course, if this is a load, that means that RT is the one register that is giving us where to write. So this one is going to be a 0. Okay, so register destination is going to be 0. We don't write memory. We don't write memory. So 0 here. The ALU source, we said it was 1. That was a given, and register destination was 1. And of course, the ALU control here, this one here, is 2 zeros because this is an addition. Did I do that right? Yes, it's 2 zeros. Okay, so you can check, actually, you can look at this one. We said we can look at let me see, we can go back to this slide and check it out. Register destination is a 0, ALU source, meant to register, these are all 1. So if you check that out, that back, you'll see that we are right. It's 0 for jump, 0 for branch, 0 for register destination, as we just said. Memory to register is 1, register write is 1, mem to read, mem read is 1, mem write is 0, branch is 0, ALU operation is going to be, excuse me, it should be larger here, it's going to be 2 zeros as well, and jump is a 0. So that's the example where we can easily figure out that this is a load instruction, right? And we don't need much more to know than that. So let's say that, let me change these to a different color. Okay, so what would happen actually if we change this, if this was not as 1 but a 0? So something will be messed up here. Okay, so what happens here is that we use the ALU to add and get the address, right? This address to read memory is calculated here at the output of the ALU. So this address is actually set here. And if we change this value, if we mess up and change this value with a 0, this is what's going to be sent to the registers. So this is all wrong. This thing is actually calculating an address that needs to be read in memory, and we do read that memory, but we ignore the output out of memory, and what we actually write in registers, in the register given by RD, is the address. This thing is calculating an address by taking the immediate value and sending it here and writing that address in register. So it's not loading what we read from memory, but it's storing some address calculation in registers. We could say that this is actually behaving like a add immediate instead. But the additional thing that happens here, which is that we are reading data out of memory, but we are ignoring it. Okay. Okay, so let me exit these. Okay, so this should be it for the first one.